You're listening to the Cannabis Reporter Radio Show with Snowden Bishop.
Welcome to another episode of the Cannabis Reporter Pro Series. I'm Snowden Bishop, and I'm happy you could join us. Today we're featuring Blue Mountain Energy, leading experts in energy efficiency solutions and exclusive distributor of the Sierra Fresh gas-powered climate control system for cannabis growers. If you work in the industry, you know that indoor cannabis cultivation requires precision climate control and consumes massive amounts of energy, which can be very costly when you factor in the number of heat-intensive grow lights you'll need for the size of your canopy. Beyond the cost, energy burdens can present zoning and permitting issues, especially in areas where the local grid is already tapped. In fact, the amount of energy required per square foot of canopy could limit the size of your grow, regardless of the size of your facility. Infrastructure upgrades to accommodate the amount of electricity you will need to maximize growing space in a larger facility will cost a fortune. But what if I told you that you could actually increase the size of your grow and reduce electricity costs by up to 80%? Well, as I've learned in the last few weeks, Blue Mountain Energy has made that entirely possible, and our guest, Eric Riccardi, is here to explain exactly how. For more than 20 years, he's been researching and developing cutting-edge technology leveraging natural gas as an alternative for powering heating, ventilation, air conditioning systems, or HVAC systems, for Blue Mountain Energy. In recent years, this technology has proven to be especially valuable for cannabis growers because of the incredible savings in both energy consumption and cost. Eric, thank you so much for joining me today. I'm really looking forward to this conversation.
Oh, I really appreciate the opportunity to be able to talk about what we're doing and trying to do for the cannabis industry.
Yeah, absolutely. You know, I'm pretty excited about MJ BizCon. So I understand that Blue Mountain Energy is going to be there with a booth, and you're going to have an opportunity to tell growers how they can save a bundle on HVAC costs just because of this technology, which you refer to as the gas heat pump technology. And just for those who haven't already seen your profile on our website and who really aren't familiar with the technology when it comes to HVAC systems, tell me a little bit about that, like just the bird's eye view.
Well, if you can picture, typical air conditioning systems that might be used for cannabis facilities or really any type of building, those air conditioning systems run on electricity primarily, especially for cooling. Almost all mechanical cooling equipment is electrically driven. The main difference here is our condensing units run on natural gas. So we displace the electricity that would be necessary for the mechanical cooling. So everything from our condensing unit forward into the building is the same as an electric multizone VRF air conditioning system. It's our condensing unit is a 4-cylinder natural gas Toyota engine with belt-driven scroll compressors that running on natural gas. We're using almost zero electricity to heat and cool the building, which results in a tremendous operating cost savings, along with other environmental impacts that a lot of folks aren't aware of, just by switching over to natural gas from electric.
See, I find that to be completely amazing. And it's actually really good news because I remember when Colorado first passed their adult use law several years ago now, a lot of growers were sort of gravitating toward this one area near Denver where there was an industrial park and perfect opportunity for them to take space in these large warehouses and set up grow facilities. And they basically started crashing the local grid, which to the astonishment of the city planners who were granting permits for these grow facilities. And I think they had to do some pretty immediate work to redistribute, like how they were going to give out licenses and what size grow could be accommodated in these areas where the grid was already taxed. I just don't think they anticipated the high intensity lights and the power that needs to be drawn from the grid just to run these air conditioning and heating units. So just from your perspective, what is going to be the real difference when it comes to the energy consumption for someone choosing a gas heat pump version of the HVAC system versus a conventional air conditioning system that draws thousands of BTUs?
Well, gas is a lot less expensive than electricity. As a matter of fact, natural gas most of the electricity in the U.S. is manufactured by natural gas at the thermoelectric plant. So gas is abundant, very inexpensive compared to electricity. And aside from just the operating cost advantage, we see operating cost advantage for our equipment over same-sized electric equipment up to about 50, 60, in some cases even 70%, because we're eliminating 90% of the electricity that would be necessary to drive those electric air conditioning systems. So depending on local rates for a facility, for a grow operation, and what their electric rates are versus what their gas rates are, it's a tremendous operating cost advantage, which is becoming more and more important as the cannabis industry becomes more competitive. As there are more licensed folks, you really want to pay more attention to your operating cost moving forward, whether it's through building automation or energy efficiency and savings, because as the price per pound goes down for your product, your operating cost is going to become more and more important. And that's where we really shine. There's a lot of other ramifications to consider as well when planning a facility. We saw a lot of folks that wanted, a certain amount of square footage for an indoor grow facility. They finally find space that's zoned that they can move into and open their facility, only to find out that there's, a 1,200 amp electric panel on the wall. That's just not going to be able to handle the number of grow lights and the mechanical cooling that you're going to need indoors. And, they'll get a hold of the power company and maybe look for an electric upgrade, which can be hundreds of thousands of dollars, and not to mention a year, 14 months, 16 months on a waiting list to get the work done. We can eliminate that necessary power upgrade just by shifting the HVAC load to natural gas. And we've helped out dozens of cannabis cultivators that either wanted to expand or just didn't have enough initial power to build out. So aside from just the operating cost moving forward, an initial savings on avoiding an electric upgrade are tremendous.
Well, not to mention the profitability factor. I mean, if you've got a 10,000 square foot facility and your electrical panel can only accommodate 4,000 square feet of that facility to run the lights and the cooling and partition it off so that, you're not wasting the energy that's being used to control the climate of the grow, now somebody can say, well, with the same size panel, this is what I'm reiterating what you said. So now they can go in and actually fill that 10,000 square foot space, so to speak, and use the same amount or use even less electricity than they would running 4,000 square feet. Am I right about that?
Oh, absolutely. Yeah. Our rule of thumb is we're going to eliminate 90% of the electricity that would be necessary for same-sized electrical, mechanical cooling equipment. Our equipment is expandable. It's a multi-zone system, so this system can be installed as either a multi-zone system with multiple fan coils, each one with their own temperature control or remote sensor that can be hung right in the center of the canopy of the room for even room temperatures. Or we can install the system with our plate and frame heat exchangers as a chilled water system as well. It's versatile and perfect, really, for the cannabis industry. It really has been kind of a marriage made in heaven when we saw this industry kind of grow up in front of us and started working with engineering groups and owners alike to install this equipment.
Yeah, that's pretty amazing, actually. And if someone already has an existing system and they want to basically upgrade to the gas heat pump system, what kind of changes are they looking at? And I suppose you would cost it out per square footage or something like that, but what would they be looking at to transition their existing system? And would they have to replace all of their softening and ventilation systems and all of that, or is it just something that can easily replace like the main unit?
Well, we are a split system, so if you're replacing rooftop package units, those tend to be installed differently than a split system. A rooftop package unit or a unitary package unit, they're quite common on low-rise buildings. That's the type of system that's ducted into the space and then distributed within the space. We are a split system, so fan coils, either ducted or ductless, can be installed in the space, either with distributive ductwork on ducted fan coils or ductless cassettes hung typically right at light height. And these cassette units have a 360-degree louvered air discharge for even distribution throughout the room. Or with our chilled water systems, if it's a retrofit of an existing chilled water system, we can replace that electric air-cooled chiller or the water-cooled chiller cooling towers with a closed-loop chilled water system using the gas heat pumps and our plate and frame heat exchangers that is so simple to install and maintain compared to an open-loop system. And by the difference between open loop and closed loop is an open loop system, you have a cooling tower, there's a lot of water usage, a lot of water waste, a lot of water treatment and ongoing maintenance. Our system is a closed loop system, so there's no cooling tower. We're using our air-cooled gas heat pump condensing unit to cool the refrigerant for the chilled water system. And being a closed loop system, there really is no maintenance. Once you start the system up and adjust the glycol in the water, so there's a huge benefit to that as well, getting away from open loop systems. And it's really not just the cannabis industry. It's the HVAC industry as a whole is moving away from open loop systems because of those maintenance issues. And it's just a lot of maintenance on cooling towers to keep them clean and treat the water.
So the water chilling system, that's basically for the air climate?
Correct. The difference between a chilled water system and a multi-zone split system is really with a multi-zone system, or in the industry it's known as a DX system, direct expansion. You're moving refrigerant inside the building through fan coils and returning the air within the space through the fan coil and back into the space. With a chilled water system, you're moving chilled water instead of refrigerant through fan coils. and then circulating the air from within the space through those fan coils.
I think that's fascinating, and here's why. I think that Freon is going to be banned in a lot of different places in the next couple of years, from what I understand. You might know more about this than I do, but it seems like it would be an incredible advantage to have a system that's cooled with water as opposed to having some kind of refrigerant chemical running through, especially if people are going to start replacing their units. They're going to need to. They might as well consider this, wouldn't you think?
True. Actually, within the industry, not necessarily a ban on Freon. Right now, the industry in the U.S. is using R410A is the current refrigerant of choice. Previously, it was R22, and they began to phase out R22. And as they began to phase out R22, because of the fluorocarbons within the refrigerant and, their reaction to damaging the ozone layer, essentially, when they started phasing it out, R22 became very expensive. It became prohibitive to fix your old R22 system or repair it anymore. So essentially change out your entire system. There is talk in the industry that, someday they'll be phasing out 410A. It's not something that really too concerned with at this point in time, because there'll be a drop-in refrigerant replacement for it, just like came out for R22 in time. But, there is that thought process there that if this refrigerant goes away, it could become more expensive. But so in other words, I don't want to downplay, the ease of installation of a R410A refrigerant-based split system. It does its job for sure. And the difference really between selecting a DX refrigerant-based split system or a chilled water system, a lot of times that falls on the application or just a preference of the grower or owner of the facility, ease of installation, so on and so forth.
Let me back up and ask you again about with the water-cooled system. I know that that's primarily for regulating the climate in the air, but does that also control the water temperature in the aqua hydroponic type of cultivation? And can the water cooling system actually help to regulate the water temperature in those grows as well?
Correct. Our gas heat pumps are heat pumps, so we can heat and cool. So we can actually, our system can switch back and forth between heating and cooling very easily. So we can keep a constant water temperature if that's desired for a hydroponic system.
You couldn't do that with a regular air conditioning unit, as far as I know.
No. You need a chilled water system, water chillers, either air-cooled or water-cooled chillers, and a boiler for hot water to maintain a temperature range.
Right. So if someone's setting up an aquatic growing system for a cultivator who wants to primarily, grow in stacks in the hydroponic system, right? Could one system handle then both, all in one system, as opposed to having them get two different systems, one for their water regulation and one for their air?
Correct. Correct. And any type of space conditioning or water conditioning, our system can handle. And I know it's probably, just talking about it might be a little hard to envision. But yeah, to be honest, typically we see one or the other in a cultivation facility. Either they're running chilled water or they're running DX air conditioning systems.
Yeah, but if they are growing in water, then they can have one central system that will handle both the air climate and the water climate. That's going to save a lot of money just in equipment, wouldn't it?
It may, depending on what they're planning on installing or what they currently have. I will say if if not a lot of money on the equipment side, definitely a lot of money on the operating cost side.
Right. Yeah. And it seems as though with the savings in energy costs, the systems would basically wind up paying for themselves. I mean, how do you advise people about that?
We'll do a life cycle cost analysis for anybody with just some basic information, such as square footage, if it's an existing facility, the number of the tonnage of the system that they're running now, their zip code, so we can pull down the utility tariffs for rates. And we use local weather bin data and estimating run hours. We can run a life cycle cost analysis, which is free of charge for anybody to determine what that return on investment would be. So essentially be able to show them and in charts and numbers what the operating cost would be with the gas heat pump systems and what their operating cost would be with whatever the alternative equipment that they may select to use. And, depending on what their rates are, their electric rates, their electric demand charges, and what they're paying for natural gas or propane. I neglected to mention earlier that our system will run on propane as well as natural gas. With just a push of the button, it'll switch over and run on propane if necessary. But the life cycle cost analysis will show them what that return on investment is.
And you'll also be able to tell just with the basic information whether or not they'd need to upgrade their infrastructure if they stayed with the typical electric system, I would assume. Am I right about that?
Oh, correct. I mean, if they a lot of times the customer knows that already. We get a lot of customers who existing facilities that want to expand, and they know they can't because their panel is maxed out. So maybe they did only build out 5,000 square feet of grow space in that 10,000 square foot warehouse, and they know they can't expand on their panel. So, we can replace their HVAC system, free up the electricity that they need for the lights in the entire 10,000 square foot space, and shift their cooling to natural gas instead of electric. And then, they avoided a tremendous electric upgrade and very expensive, and their operating costs moving forward is, like I said, could be 50% less than it was on the electric system.
I mean, that's amazing, really, when you think about it. So, and you read my mind when you started talking about the propane, because it occurs to me that there are some very cost-efficient spaces available that are sort of off the beaten path and, in a place that's not an industrial area, but where they've got lots of land to sort of sprawl out in an indoor greenhouse facility. And the ability to run on propane seems like that would be an incredible advantage for rural areas. So if they are growing sort of off-grid somewhere, I mean, is it feasible to have a propane tank without having to fill it up every 2 seconds, that they could run a system on the propane that they have access to?
Oh, absolutely. Most propane customers, have a large propane tank on site, and there's even electronic monitoring now with the propane companies. So essentially an electronic monitor on the tank to show the level, so they can schedule propane deliveries to fill the tank on a regular basis. So there's no fear of running out of propane and not being able to run your propane equipment.
That's incredible. And I think that's one of the biggest advantages that I can see, aside from just the savings in the power that you're drawing from the grid, which gives you more space, the profitability of that, the scalability of having a system like that seems like it would just make all the difference in the world. So As we start to kind of wind this down a bit, do you have anything that you feel that our audiences should learn?
Well, the numbers speak for themselves, really. It's you're not going to find a more energy efficient, effective system from an operating cost standpoint than the Sierra gas heat pumps. And we'll run a life cycle cost analysis for any customer for free and show them the savings just by switching over to natural gas. And there's so many applications where, to be honest, it really becomes a no-brainer because, we can help avoid electric demand charges and electric upgrades for facilities that the equipment will pay for itself immediately. And then there's a operating cost moving forward associated with the equipment. So, really, just let us be able to show you how much that you can save using this system. It's easy to install, easy to maintain. We have a great contractor network throughout the United States. We've been installing this equipment since 2009 here in the United States. The equipment is manufactured by a member of the Toyota Group. And you see that quality throughout. So it really is a easy to install, easy to maintain, reliable air conditioning or chilled water system that's going to save you money. And I can't think of any other type of system out there that actually pays you back when selecting the system over an alternate system.
And HVAC units in general are expensive. The conventional types are expensive. For a 10,000 square foot facility, cost-wise, if they're starting fresh with a brand new unit to manage that size space, what would be the difference in cost between a conventional unit and a gas unit? Is it more expensive to install, but you save so much that it pays for itself, or are they pretty comparable across the board?
The gas equipment, because we're engine driven, it is more expensive. So it is more of a capital expenditure for the equipment itself, not necessarily for the installation. Split systems, pretty much install the same across the board. So it's not necessarily the installation, but the equipment is more expensive. But with the operating cost advantage that we show, we show return on investments of under 2 years in the cost difference between what they would have paid for a cheaper electric system versus what they would pay for the gas system. And now if you throw into the mix that they avoided an electric upgrade, all the necessary switch gear and feeder wire that would go in association with that, it could be an immediate ROI.
Yeah, and not to mention just the cost of powering it up every month.
It really is application specific. That's why we say, let us take a look at your facility, at your needs. If it's a new construction and you haven't built out yet, let us take a look at your needs, what you're considering, what your challenges are, and we'll provide a cost analysis study and a solution.
That's fantastic. And I'm going to be putting all of your information up on this podcast post on our website, but also I will direct people to the company page that we have set up for you on our website, and then direct people also to your website so that, they can get a feel for all of the different services that Blue Mountain offers. And your company's been around for a long time and has serviced some pretty substantial clients from, the government and institutional level to the, simple indoor agriculture facility, of all different sizes and shapes. And so there's no question that when people do contact you to get an assessment of what their savings could be and to have you really sort of analyze their system, there's going to be a lot of bang for a free buck at that point. But, even once they invest in the system, it just seems as though, like you said, it's a no-brainer for them to get a return on every inch of agriculture that they're growing. So, kudos.
Yeah. And that's that's what the end game is. How many pounds a year are you able to produce from your facility? How many cycles per room or space? How much of your space you're utilizing? The overhead that is attached with that is going to determine your profitability. So if we can keep a building or a facility at a peak electric demand and lower their operating costs dramatically, then their profitability goes way up.
Yeah, there's no doubt. There's no doubt. Well, I do appreciate you explaining all of this because this technology really is pretty cutting edge. And until I had heard about Blue Mountain Energy, I actually wrote a story about your company when you were working with the Next Air Systems. Oh gosh, 9 years ago by now, when I had AZ Green magazine, because from a sustainability standpoint, there really is no better way to sort of reduce your carbon footprint if you have to run HVAC systems in a large facility. I mean, it just seems as though this is an ideal solution. And, some will argue that natural gas could be just as brown as electricity that's being run on coal, the way that it produces a lot of energy for people. But there's no question in my mind that the environmental footprint of not having to run chemicals to chill your system and the carbon output of running natural gas versus taking electricity from a coal-based grid, it's a no-brainer from a sustainability standpoint. So that's pretty exciting to me as well.
Well, you touched on something that a lot of people aren't aware of, which is that you actually, when you use natural gas directly, you actually are creating a smaller carbon footprint. And a lot of people don't think that way. They think burning natural gas, it's a fossil fuel. I'm putting carbon into the atmosphere. Yes, you are. But most of this country's electricity is produced by coal or natural gas. And if you use natural gas directly, it's a much better use of the primary fuel. People don't necessarily understand that when you use any type of fuel, whether it's coal or natural gas, to generate electricity, 72% of that is lost in the generation and transmission. So yes, electricity is very efficient when you plug something in at the point of end use. But 72% of energy was wasted in the generation and transmission. So you're pumping a lot more carbon into the atmosphere generating electricity than you are using natural gas directly. Aside from that, 2 gallons of fresh water are evaporated for every kilowatt hour consumed at the point of end use. That's the national weighted average. So it goes up or down in different areas of the country, depending on how they're producing electricity specifically. But the national weighted average is 2 gallons of fresh water evaporated for every kilowatt hour consumed at the point of end use. Just to simplify it, by every 15-ton gas heat pump that you install and displace 15 tons of electric air conditioning, you're saving 10,000 gallons of water a year. Does that wind up in the customer's pocket? Does it show up on their water bill? No. but it's a very important environmental impact. A lot of people don't understand that there's a tremendous water consumption associated with generating electricity, and where that electricity is coming from, and how it's being produced, and the tons of carbon being pumped into the air in electric generation. So, there's some areas of the country that are on hydroelectric, and nuclear generation doesn't, create the same amount of carbon, but it's still on national average. It's all across the U.S. It's 2 gallons of fresh water for every kilowatt hour consumed at the point of end use, and that's tremendous.
Yeah. And, for people who are paying attention to the science and the reports that are coming out of the United Nations, and there is a crisis that we face right now, and every little bit that we can do to reduce our carbon footprint, reduce water consumption across the board, whether or not we're paying for it, like you said, transition away from coal as best we can, as fast as we can, it's really going to make a difference, because we are approaching a tipping point. And, there are a lot of people who think that it's just a natural cycle that happens every million years, but there's plenty of scientific proof that we are contributing to the extremes that we're experiencing now, from the fires and floods to the superstorms and hurricanes and storm surges that are flooding huge cities. And, we've got to start paying attention to these things. And, most people who get into the cannabis industry, they're thinking that this is a very green industry to be in, because you're growing a natural substance that's going to save lives and eliminate a lot of other problems, from mass incarceration all the way down to the war on drugs and the cost of that. So, they're a pretty conscientious bunch. And everyone who has a conscience about those sorts of things tend to really want to do something about the climate crisis without really knowing, oh my God, how are we going to do this? It's such a daunting task. And so I'm glad that you mentioned that, because this is one way that one of the most carbon intensive industries to become less energy consumptive in a major way. And that's nothing but good. So.
Correct. Everyone would love if we had reliable, renewable, 100% renewable power. But we're not there yet. The technology's not there yet. The country's not there yet. It's expensive. There's limitations. But natural gas is absolutely the bridge to that, the means to the end. In that aspect.
Yeah, you're absolutely right. And there are also some new technological advances that are preventing the loss into water tables when it comes to fracking natural gas, because I know that that's been a big concern of a lot of people who are following the environmental issues that we face right now. But actually, I interviewed someone last year who was making this loss prevention material that has been typically made with petrochemicals, making it out of hemp, which is not leaching as much of the dangerous toxins into the water table, and, sort of preventing those leaks from happening during the fracking process. So, and it is a bridge. It's a great bridge that is more sustainable than coal. And, it'll get us by with a lot lower carbon footprint. So it's fantastic. Well, I'm so glad that you're out there doing what you do, and I think it's making a difference. And I encourage everyone who's going to be in Las Vegas for the MJ BizCon to swing by your booth. It'll be in the directory for sure, and I will put your booth number up on our website as well when I post this Pro Series episode. So, I just have to say, these Pro Series interviews really are the lifeblood to our educational program. So we really appreciate your support by doing this with us, and we are so happy to be partnering with you, and I really appreciate it, Eric. So thank you so much.
Absolutely. Thank you, Snowden. And yes, I'll be there. I'll be at the booth all 3 days. of the conference throughout the show. So I look forward to seeing everybody.
That's great, Eric, and we'll be there too, and hope to see everyone there. So as we bring this to a close, I hope you've enjoyed this episode of the Cannabis Reporter Pro Series sponsored by Blue Mountain Energy. Once again, I'd like to personally thank our guest, Eric Riccardi, for sharing his insights and knowledge with us today. If you'd like to learn more about the work that Eric is doing at Blue Mountain Energy and how they can help save your cannabis operation up to 80% on electricity use, please visit us online at thecannabisreporter.com and click podcast to find this episode. And that's where you'll find his bio and details about how to reach him directly at Blue Mountain Energy. Also, if you're planning on attending MJ BizCon in Las Vegas, please be sure to look for Blue Mountain Energy's booth at the exhibition hall. Eric will be there, and he'll be able to explain a lot more about their energy-efficient technology. On behalf of all of us at the Cannabis Reporter, I'd also like to express our gratitude to Blue Mountain Energy for supporting our educational platform as a Pro Series sponsor. I'd also like to thank our production team and all of our partners who support our work here at the Cannabis Reporter. If you work in the cannabis industry and would like to showcase your company or share your expertise as a featured guest on the Cannabis Reporter Pro Series, please send us an email to publisher@thecannabisreporter.com to request a media kit or just drop us a line to say hello. And last but not least, thanks to all of you for listening. I'm Snowden Bishop, inviting you to join me each week for the Cannabis Reporter radio show. And until we meet again, be safe, stay informed, share what you've learned, and make it a great day.
You're listening to the Cannabis Reporter radio show with Snowden Bishop